going to add other things, and we're going to still keep some of your mins and maxes you're increasing. We're going to add a bunch of other things into this. But I want you to be able to describe, and we have a routine. The exponent is how many zeros? Minus 1, how many terms? Minus 1, how many inflection points? And today we'll get to those. So this guy has odd. Down on the left, up on the right, because he's positive. And this one, same thing. And it had 5. I should see this cross the x-axis 5 times. And it's crossing my x-axis 5 times. That's where the 5 comes in. This guy is turning down. Okay, I have 2 roots, and it's turning down. This guy here's a negative with a cube root. I should see 3, but remember when it bounces off the axis, there's your double root. So the left side now is going up, the right side now is going down. And I wanted you to remember, I said try to do it without plugging it into your y equals. Try to do it based on describing it. Here's a 4. I should have 4 times it crosses the x-axis. 1, 2, whoop, that's a double. 3, 4. And I'm negative, so my ends are opening down. My ends are behaving down. This guy is a plain old line, but it still follows the rule. Watch. This is x to the 1. It's an odd exponent. Odd says up on the left, down on the right, because this guy is negative. So it's still behaving the way it should. How many roots should I have? 1. How many times did it cross the x-axis? 1. It still follows the same pattern. This one was a little harder to see because it couldn't get so close right in here. But 1, 2, 3, you should have had 4 or maybe a double root in there. It's kind of close. We knew our both ends had to go up. Here's one with the 2, and they go up. So my goal through this was start describing. Start getting used to describing them. See how many times it crosses the x-axis. There's your zeros. Okay? All right, these, you might have went a little too far. Again, just follow the directions. I wanted you to describe them. So we see this has a coefficient of a positive coefficient and an exponent that's even. Therefore, my end behaviors should be up, left, up, right. They behave the same. I've got a positive coefficient. My degrees are 4. I have 4 roots, 3 terms, 2 inflection points. We'll start doing this again today.
You got the up thing from it being even?
Well, it's even. That was a 4. I kind of wrote right over it. And this was positive.
So a positive gives you that?
Yes. What is your parabola? Think your basic parabola. What does that look like? It goes up. Don't the ends behave the same?
Yeah.
What does this look like? It goes down. All even exponents will behave that way. Their ends will behave that way.
So how could you know if it was like one's left and one's right?
One's left and one's right. They're on the odd ones. And then what happens is if this is positive, it goes down on the left, up on the right. If it's negative, it'll go up on the left, down on the right. And all the odds will behave the same. All the evens will behave the same. The highest exponent, that's your degree of your polynomial, the highest exponent. Left hand, so if we just did this, did you take the notes from yesterday? Yeah. Yeah, there are pictures on there. So if this is what I'm looking at, watch, here's my parabola. This says left side up, right side up. Their big ends are behaving. Where's my end going? My ends are going up. Okay, if I'm negative, my ends are both going down. Okay, and the odd ones go the opposite ways. They don't behave together. They go, one goes down, one goes up, depending on positive or negative. So follow the diagram. Now, notice, look where they put your highest exponent at the end. So go to this guy. I have 2 roots, What's my coefficient? Negative. So where are my ends going to behave? Down. Down left, down right. All I want you to do, confirm it in your calc. If it says confirm it with a graphing utility. In other words, your calculator. So put it on your calculator and confirm that your ends are behaving that way and that you had that many roots. You'll see it cross 2 times. This guy, be careful of this guy. You have to distribute this. So your leading coefficient is now negative. Your negative coefficient, it's an even, so where are your ends behaving? Down. Left and right will both be going down. It's still a parabola. It's a parabola with a reflection and a little bit of a shrink to it. So it's a little bit wider. So the key there was describe. Make sense out of these. If you make sense out of these, it makes your life so much easier. This part, I asked you to find the zeros, like we did yesterday. So we set your y equal to 0. This is the same as your y. We set it equal to 0. We wanted to know where does it cross the x-axis. It's called the zeros, the roots, the solution. Most of the times we will call them the zeros or the roots. Your zeros also, we did your x-intercept. Your x-intercept, we did your y-intercept the easy way. We just covered your x's and saw where your y-intercepted. We're doing a sketch. Does it mean you have to go 25 little tick marks down? Nope, just give me a sketch. Okay, so can everybody find this? Now, I threw this word out here. It's called multiplicity. Multiplicity means, did this repeat itself? Did it multiply by 2, multiply by 3? If your roots are single roots, the multiplicity factor is 1. If it's a double root, like this guy had a double root because look, it was t minus 3 times t minus 3. It had a double root. That's called the multiplicity factor of 2. Means it just did it twice, the same, 2 the same. Do we really use those? We don't really use that too much in describing, but you might see it. We do say double root. And the double root, if you remember from yesterday, will bounce off, not go through. A single root will go through the axis, where a double root will bounce off of it. So everybody has these? Okay? For some odd reason, it's a little off. Either that or somebody moved something. Okay, so now, this guy had an x squared. Means I have to have 2 roots. I factor this, and I can find my 2 roots. This guy had an t cubed. Factor out a t. Factor this guy. There's a double root right here. This is a double root, which means I'm going to pass you the 0, but I'm going to bounce off the 2. Now, if we did this and we didn't graph this in our calculator, we would say this. I have 3 roots. I have 2 turns, and today we'll get into inflection points. I have 1 inflection point. I do my zeros. Where's my y-intercept at? If all of these t's are zeros, where's my y-intercept at? 0. So I know my y-intercept is at 0, 0. I know these are my roots. I know this is a double root. So watch how we can graph this. My end behavior says you have an odd, and it's positive. Where are my ends going? Down on the left, up on the right. Good. So now, down left, up right. I don't need my calculator. Watch. I have a root at the 0, 0, and I have a root at the 2. It came from the down part. This guy has to go up at the right. This was a double root, So it's not coming through, it's bouncing off. This guy's going through. So somewhere, I just got to make this turn. And I know what my graph looks like. I don't even need a calculator. I may need a calculator to see how exaggerated this is. It may go up skinny like this. It may be flat like to the axis. That part I don't know. But for the most part, can I get my sketch? If I know how my ends behave, if I know where it crosses the x-axis, I can even do my y-intercept. And I should be able to find it. I should be able to graph these without my calculator. Don't give everybody away, Violet. Okay, so what else we got here? All right, this one. Yep, this one had a little bit of a fraction. But look what happened when you factored out that fraction. Did I give you this one? Look what happens when I factor out that fraction. I divide everything by 1/2. When you divide by 1/2, you keep, you change, you flip. 3/2 by 1/2, keep, change, flip. God bless you. So now it comes normal. I can get rid of that 1/2. I don't need that 1/2. It doesn't affect my roots. I'm getting an x squared, positive coefficient. My ends are behaving up. I can find where I crossed. Yeah, I crossed at some weird looking number here, but I can estimate approximately the square root of 37 would be what? Approximately close. 6, right? 36 would give me 6. So what is 6 divided by 2? 3. So I got negative 2.5 plus 3. Oh, that puts me right over to the other side right here. And I got negative 2.5 minus 3. Puts me over here somewhere. My ends are behaving up. And somewhere, I'm making a turn. I can graph these without a calculator. Because I look at my end behaviors. I look at my roots. Okay? I don't know how big it gets. That's okay. I can figure that out on my calculator when I need to know my max and my min. But I can get a rough sketch. Right? But just be careful when you divide out. When you do this, you divide everybody by 2, right? Well, don't forget to divide everybody by 1/2. It forces you to keep, change, flip. Okay? Questions on this at all? What do you think this looks like? First of all, how many roots do I expect? 4 roots. How many turns should I get? 3. Good. -1 gives me 3 turns. Did we talk inflection points at all yesterday? Okay. 1 less, 2 inflection points. Okay. Let's talk end behavior. Where should my ends go? Both up. Positive coefficient, even, exponent, both up. Right up, left up. God bless you. Now, let's find your roots. Let's find your intercepts. What's your y-intercept if I take out both my x's? 0. If I take out both my x's, my y is 0, right? So let's plug in a y of 0 and see what my roots look like, because that's going to help me graph this thing. What can I factor out? X squared. And you can do this a number of ways. You could say, give me your perfect squares. You could set that equal to 25. I don't care which way you do it. Oops, sorry. I'm saying 25 and writing 25. As long as you come up with something. So look at this guy. When we take the square root of 0, this is your double root. So now, can we kind of sketch this? Let's see if we can sketch this. I pass through the 0 That's where I'm going to bounce off. Oh, that was mine. By the -5 and the +5. Looks like I'm pretty symmetric here. Where are my ends going? Up. My ends are going up. And somehow these have to come through because they're not doubles. I somehow have to meet, I got a W. This guy can't go through. He's got to bounce off. So I got a W in here. Pretty good. Who would have thought that that whole graph gave us a W? Now, we don't know how far they drop down. We don't know how far they do. We can pretty much figure that it must be symmetric because we're the 5 and the 5. Jeremiah?
Based on the equation, how would you point out how many turns you have?
Well, it's a pattern. Start with your 4 roots, subtract 1, that's how many turns. Subtract 1, that's how many inflection points. So here's my turns. Here's my 4 roots. 1, 2, 3, 4. Here's my turns. 1, 2, 3. And inflection points we're going to get to in a minute. So I can pretty much know a lot from this. Now graph it in your calculator. Let's see what it looks like. If those points were 5 and -5, if they were like 3 and 2, then I'm not symmetric. So then maybe my W is a little bit off in one part of my loop. But I can pretty much figure that those must be symmetric. And we're going to label these A, B, and C. Because we're going to find A and C are what? These are called what? Well, no, these are your minimums. What kind of minimums are they? Absolute minimums. Good. These are your absolute minimums. And what is B called? A relative maximum. We know B already, don't we? Because don't we know where it intercepted the y-axis and the x-axis? So we know this already. Because that's where we had we intersected the y at the 0, the x at the 0. Now, if this is symmetric and I find A, shouldn't C be the same point just with a different sign of the x? So find me A. Not a trace, second max. You got to do second calc, do number 4, max. No trace. I'm sorry. Minimum. Sorry, minimum. I was saying maximum. Second calc. Don't do a trace on this. How many decimal places do we want this? 3. You may have to change your window. These are pretty far down. When you can't see a turn, what are you going to have to change? Yeah, so you got to go a little further. Oh, it still did it? Okay, good. That's it. So give it to me in 3 decimal points. So, if I know that one, then I know this one must be the positive x. But still the same y. So now it will look like a W, it just happens to dip pretty far down. And that we don't know when we're doing this. Now, domain. Can you guys give me the domain for this? All real numbers. I can use any x I want. Can I even look at my table and see that there's no errors? I can use any x. How about the range?
You can make the window.
Well, you got to change your y window. Go like -200.
For y min, negative 2.
For y min. Y max? No, y max is fine. Y max you can make 10.
Oh, you don't need to see.
You don't really need to see past the 0, 0, really. You just need to see across the x-axis. Yeah, so you just need to change your y min. Sometimes it's confusing with the y min because we want to change the max all the time and not the min. Yeah. So what's the range? Where do I start? Negative, and we're going to give it a hard bracket. Even though we rounded, we're going to give it a hard bracket to infinity. Okay? Where am I increasing? I've got increasing, decreasing. We've done these before. My y starts here. He's decreasing, decreasing to what point? X value. Negative 3.56. Always go off your x value. Because my y, if you gave it to me that way, it would go like this. From here, straight down like this. I wouldn't know where I moved to. So my y is decreasing during this x value. Then I increase from here to here. So at the negative 3.56 to the 0. Then what did I do from B to C? Decrease from 0 to 3.536. And then what did I do from C on up? Increase. To infinity. So I get all my increase and decreases. I get everything else the same. I know my roots. I know my intercepts. Okay? Now, all I have left is my concavity. Is everybody okay up to this? And then we'll do the inflection point. Now, when we see a cave kind of looks like this. This is a cave. That's a cave down. A cave up is just the other way. So we're going to look for something that caves up or down. So we notice that this caves up. This curves down. And then what did this do? This curved up. So where they overlap, which is here and here, we have to share that part. So we cut it in half at the midpoint. Okay, we're looking for our caves. Actually, the only new thing is your cave. The cave up and cave down. Okay, so let's watch again. You just told me, Dave, you told me where I caved up. You saw the cave down, and then I caved up again. Now, look at my colors. I've got a green and a blue on both of these pieces. That means I use the same piece to cave up and cave down on. So when we do that, we take the midpoint of this. We're going to call it D and E. An inflection point is the midpoint. Midway, write this down, between a cave up and a cave down. Midway, midpoint. So when you find the midpoint for a line, what did you do? How'd you find the midpoint in geometry? No. How do I find the midpoint of something? You're going to add the x's and divide it in half, right? If I have a line like this, it starts here at 4, it ends at 10. How do I find the midpoint? Add it, divide it by 2. So, we're going to take the x values, add them, and divide it by 2. But look at this x value. This x value is negative 3.536. What's this x value up here? 0. So when we add negative 3.536 plus 0 and divide it by 2, what do we get? Negative 1.768? Thank you. Should I get the same thing over there since this is symmetric? It's not always symmetric, but this just happens to be symmetric. Now, we got the x value. We could do the y's, but sometimes it doesn't always work with the y's. So we're going to go to your calculator, and we're going to let your calculator tell us what the y is. So go second calc, number 1 value, and when we see that x equals, put in either one of these, negative 1.68, 1.768, or positive 1.768. It doesn't matter. They're both going to have the same y.
How did you get that together? You added.
We added this x value plus this x value to come up with the midpoint,
And divide by 2.
and divided by 2. Then we put it in your calc value to find the y. So if you put it in your value to find the y, you should get negative 68.375. So I have 2 points, 2 inflection points. I just couldn't fit that, this goes right over here. We have 2 inflection points. We're almost there. Now, we're going to describe our concavity. We're going to say, I caved up, concave up. I made an upward cave, right? From negative infinity to this x value, to negative 1.768. Then what did I do from here to here? What kind of motion did I make? Cave up or cave down? Good. You cave down. Concave down from this x value to the next x value. And then from there to there, what did you do? Caved up. We got a lot going on. We always did the intercepts. We always did your x-intercepts. We always did your y-intercepts. We always did the increasing, decreasing. We always found your max and your mins. We added your concavity and your inflection points, technically. And we probably understand a little bit more about our sketch because we did your end behaviors.
That's a lot of anything.
Guys, on your homework to do them are these kind down here. So start like that. Start setting them equal to x. Find the factors. Leave them in factor form. Leave them in factor form.
Yay, we say it.